Hello everyone, in this session we want to talk about BugsInPy. BugsInPy is a bugs database for Python programs that enable control testing and debugging studies. Currently, Python is one of the most popular programming languages in the world based on the 2020 Stack Overflow Developer Survey. Compared to other programming languages, Python has several unique features, including duck typing, heterogeneous collection, and dynamic typing. Because of this, it is very likely that the characteristics of bugs in Python differ from other programming languages that are focused on previous study, for example Java and C. Despite these reasons, as of now there are not many testing and debugging tools that are created for Python. Our work is inspired based on debugs4j. debugs4j is a popular Java bug benchmark that on initial version contained 357 real bugs from 5 relevant projects. There are several appealing aspects of debugs4j that make it popular. First, it is constructed from a real-world project. Second, bugs are reproducible. That means each of the bugs is accompanied with a failing test case that passes once the bug is fixed. And the third, bugs are isolated. It means that the code changes that fix the bugs do not contain irrelevant change, such as refactoring or adding a function. debugs4j also made it easy to retrieve the bugs in debugs4j. BugsInPy architecture is similar to debugs4j. It has three main components: a bug database, a database abstraction layer, and a test case execution framework. The bug database contains the collected bug metadata with links to the original Git repositories. The database abstraction layers allow access to the bugs without the knowledge on how the bug data is stored. The test execution frameworks allow execution of tools for testing or debugging on the collecting bug data. Bugs data in BugsInPy are collected from real-world Python 3 projects in GitHub that have at least 10,000 stars. There are several requirements for bugs in BugsInPy. The bugs is in source code. That means we include only bug fixes that involving change in source code and exclude those that change configurations, build script, documentation, and test cases. The bug is reproducible. Reproducible means that at least one of the test cases from the fixed version should fail on the faulty version of the code. And lastly, the bug is isolated. An isolated bug is a bug where the faulty and fixed version of the bug code only differ in the code change required to fix the bug. This means that no other related changes are involved, such as refactoring or feature addition. To fulfill the requirement of the bug, we populate BugsInPy with real bugs recorded in version control system by employing several strategies. First is identify the real bugs. When collecting bugs, we investigate commits that modify or add test files. We heuristically identify test files as files that contain test words in their names, and import testing libraries such as unit tests or PyTest. To identify whether a commit is a bug fix, we manually look at the commit message to source code and any link information such as GitHub issues to understand the intention of the change introduced by the commit. To further ensure, we identify real bugs fixes that satisfy the requirement that bugs is in source code. At least, two authors investigate the commits independently, and we take only the commits that they agree on as qualifying bugs fixing commit. To satisfy the second requirements, that bugs is reproducible, a bug fixing commit should contain at least a test cases that expose the bug. We identify these test cases by running them on both the faulty and fixed source code version. The test cases should fail on the faulty source code version and run successfully on the fixed source code version. We identify these test cases as the ones that trigger the bug. We exclude the bug fixing commit that do not have such test cases. To fulfill the third requirement, we need to make sure that the bug is isolated. We include only the bug fixing commits that are isolated, as otherwise the failed test case may fail because of other reasons, such as non-existence of a new feature or in the faulty source code version. To identify the isolated bug fixing commit, Two authors manually check the commit and labels whether the commits also contain refactoring and feature additions. The commits are considered to be isolated if both of the authors reach the same conclusion independently. BugsInPy dataset is comprised of 493 bugs from 17 real-world projects. Shown in the slides are the source of the bugs data contained in BugsInPy and their distribution among different projects. To abstract the source code access, BugsInPy assigns a unique ID to each bug in a project where each ID is linked to the Git revision hash in the project repository. If a user requests for a file diff or fixed source code, BugsInPy will automatically find the Git hash linked to the ID and check out the source code. To abstract the build system, we learn how to build each project by reading its documentations and source code. Through this analysis, we record and automate how to build each project, removing the need to user manually configure each project. Currently, the test execution framework provides several functions. In test execution function, we can run test cases that are relevant to the bugs. By default, only the test cases that are relevant to the bugs are run. In this example, we run tests in the project black in the buggy version. It showed that the test result is failed because it's on the buggy version or faulty version. We can also run all test cases from the project. By adding test A in the BugsInPy test command, we can run all the test cases. In this example, it showed that it ran 103 test cases. Since we also ran it in the faulty version, it showed that we have 1 failure. We can also choose the test cases that we wanted to run. In this example, we choose the test empty method. The results show pass since the tests are not the buggy one. The first command in the BugsInPy command is used to do test input generation. BugsInPy uses the Python fuzz, a coverage guided fuzzer for testing Python package, as the test input generator. BugsInPy has the BugsInPy mutation command to run mutation testing for evaluating the quality of the existing tests. Mutation testing in BugsInPy uses MutPy as the mutation testing tool. We can run the mutation analysis based on the user input or from the test cases that are relevant to the bugs. By default, it runs the mutation analysis on the bugs test cases that are relevant to the bugs. Code coverage computation will show the coverage report after running the test cases under instrumentation. We use coverage.py for this purpose. It will show and distinguish the parts of the code that are being exercised by a test and the parts that are not exercised. The coverage report will show in detail the lines and pages in the project that were executed. To conclude, we present BugsInPy, a framework to enable control studies requiring experiments on real bugs in Python projects, such as work on testing and debugging. BugsInPy is currently comprised of 493 bugs from 17 real-world projects, making it the largest Python bug dataset to date. It is created by hand to ensure that the bugs are reproducible and isolated. The objective of this work is to support reproducible research on real-world Python projects. We also made it easy to retrieve the buggy and fixed version with the provided interface. BugsInPy dataset is also easily accessible, since we also provide guide to add the bugs. BugsInPy has a provided interface that made it easy to run the test cases, compute code coverage, perform mutation analysis, and generate new test input via its integration with existing tool. We plan to add more projects and bugs to BugsInPy for our future work, and we also plan to integrate BugsInPy with more testing and debugging tools. We hope BugsInPy can stimulate the rapid growth of testing and debugging tools that are targeted from Python program. And that is all from me. Thank you very much. If you have any inquiries, question, advice, or comments, you can send it to the following email.